There we go. Okay, on the first page, we're just finding the derivatives. So, for number 3, I'm going to write in f prime of x. Now, wouldn't this be chain rule? We have something on the outside, something on the inside wrapped with the parentheses. So we have to go and start from the outside to the end. What is the derivative of cosine? Negative sign. And you keep the inside as it is. And then multiply by the inside derivative, which is 1 over x. And done. All right, let's go to number 11. That was a good one, by the way, number 11. Okay.
I said that.
Yep. So on this one, we have a radical. So I'm going to rewrite that as a power first. So we have natural log of, what do I have? 3x plus 2 all squared, not all squared, 1/2, over 3x minus 2 to the 1/2. And then we should also expand it. Now, when we expand natural log that's got a division in the inside, what did we do?
Subtract.
We subtracted. And at the same time, what are we going to do to the power? Move it to the front. So let's do all that at the same time. So we have, and we're just rewriting. We have 1/2 natural log of 3x plus 2 minus 1/2 natural log of, what are we looking at here? 3x minus 2. And then we can derive. So to find the derivative of the first one, let's write f prime of x. Leave the coefficient as it is. So the derivative of just that natural log of the argument is 1 over that argument. And then we have to times it with the derivative of that inside, which is 3. Then I have minus 1/2. And again, 1 over that parentheses times the derivative of that, which is 3. And if I do want to further simplify, the best answer will be the following. It'll be 3 all over 2 times the quantity of 3x plus 2. And then minus, let's write 3 all over 2 times 3x minus 2.
We can simplify with this.
You'll see the format of it. The format will be given on each one of them. All right, number 13. On number 13, let's go ahead and rewrite this as just 2 components, not all divided by 2. So let's pull this one out. Oh, I don't have enough room. Okay, let's write out 3 over 2 e to the x. And then we have plus 1 over 2 e to the negative x. Now, if I give you e to the anything, it's really simple. The derivative and the antiderivative is itself times the derivative of the power. Did y'all see that flickering? Whoa. All right, so let's write out y prime. Leave your coefficient. The derivative of e to the x is e to the x. And if I find the derivative of that power, does that really matter?
No.
Nope. And then the next one we have plus 1/2. The derivative of that is itself times what?
Negative 1.
Negative 1.
Is that it?
You can simplify further, but I think we're good. And then the only thing we'll do is we'll move the minus 1 in front, and that will become a minus sign from a plus sign. Okay? But seems pretty redundant. Yep, let's go to the back. Back page. Okay, what number did we say on the back? 16? Yeah? All right, on number 16, now we're integrating. So we have to let u equal something, and typically it's going to work out as long as your denominator has a higher degree. Is that true?
And if it doesn't, you do long division?
Yeah, you would do long division if it doesn't. So let's do u is equal to x cubed plus 5. And that will give us du as what? 3x squared dx. What do I need to move to satisfy the given from the original?
1/3.
So we need 1/3 du is x squared dx. So now let's go ahead and put in or rewrite our integral in terms of u. Let's bring the 1/3 in the front, which gives me 1 over u du. And then when I integrate, we get 1/3 is equal to, integration of 1 over u is, I don't know why I have equal to. Natural log of, what kind of u? Absolute value of u. And then we need plus what? C. Do I leave it like that? Plug it back in terms of x. So I have 1/3 natural log of, and our u substitution was x cubed plus 5. Oop. Close it and plus c. All right, good with that one? Okay, let's go to number 16. Not 16, 19. Weird, I saw 19 and reversed the 9 around. You do that sometimes? I get it.
Yeah.
We can relate. All right, let's rewrite number 19 so the dx is on the outside. You don't have to, but I think it'll be nicer. Everyone ready? Okay, the two people still talking. Let's write integral of natural log of x to the 5th. And then for the dx part, or the bottom part of it, we have 1 over x, and then let's write dx on the outside. So then, which piece do you think will be logical for us to let u equal? Natural log, because that's going to give us 1 over x dx, okay? So we know this right here is going to be our u substitution. So let's write out, I'm going to go over here. U is equal to natural log of x. Du is 1 over x dx, which we have right there. So when I rewrite, we get the integral of u to the 5th du. So let's do a quick reminder on anti-deriving with the power other than, I don't know. So let's go ahead and try this. This will give me 1 over, what do we do to that power? 6. And u to the power of 6. And then we need plus what? C. Are we done?
No.
What do I need?
Plug
Plug
in
in the u. So we have 1 over 6. The u is natural log of x to the 6th power plus c. Done?
Wow.
So if rewriting helps, go for it. Okay? Okay, are we ready for number 23 and the first 24? Okay, on number 23, we're looking at integrating with the e. Now, typically with the e, what was our u equal to? U was almost always equal to what? The power. Okay? So let's write on here, u is equal to, let's rewrite this as x to the 1/2. So then when I derive, we get du as what?
1/2.
1/2 x, and 1 less than that is?
Negative.
-1/2 dx. Should I have rewritten this to begin with a while ago?
Yeah.
That would have been smart. Oops. So let's rewrite this. Leave e to the x to the 1/2. And when I bring that up to the top, that's going to give us x to the power of -1/2. Oops. Dx. There we go. And don't we pretty much have that right here?
Yeah.
Except I need to get rid of the 2 by multiplying, right?
So
2 du. It looks so messy right now. X to the -1/2 dx. Uh-oh, I guess we're not doing 24 then. My work is spilling over. Okay. So let's go ahead and rewrite it in terms of u. What's going to come outside of the integral? 2. Then I have e to the u du. And leave a 2 again. So antiderivative of e to the u is e to the u plus what? Plus c. And then all I need to do is plug it back in terms of x. So I have 2 e to the power of, I'm just going to write it as a radical x plus c. If you want to leave it as a power with a fraction, that's fine too. All right, questions on this one? Good? Okay, let's go to number 24 and hope I have enough room. So where's my power here that I need to make u equal to?
X to the 5th.
Okay. So let's write out u is equal to x to the 5th. So du is 5x to the what? 4 dx. And let's go ahead and compare. I see x to the 4th dx. So let's divide it by 5. And then rewrite this with the u substitution. This 3, I'm going to throw it outside. And also the 1/5, take it outside as well. You okay if I just write over 5?
Yeah.
Yeah?
No, we
Oh,
here. Like, we
don't,
here.
okay. I was like, oh no. So we have e to the u, du. And when I integrate, we get 3/5 e to the u plus c, which we get 3/5 e to the x to the 5th. Oh God, that was a really big 5 plus c.